Hello, good morning children. So in the last class of chemistry, you had studied about different methods of separation of mixtures. We had studied about sublimation, then chromatography and distillation. So in chromatography, we had studied how the different colors of a mixture, that is in a dye, it can be separated using the solvent water. And when you separate the mixture using water, that is using chromatographic technique, one important thing you have to keep it in your mind is the different colors, they dissolve in water at different rate. Some colors dissolve more, they are more soluble in water, some colors are less soluble in water. So when the colors of a dye separate, the more soluble salt will be moving faster and it will form the upper layer. And the less soluble dye, the color which is there, it will be remaining, it will form the lower layer. So please remember that, that's very important. Then we had discussed about distillation, where two liquids, miscible liquids can be separated by using distillation. That is for example water and acetone, and also we have told you about petrol and kerosene also can be separated by using that method. The main principle is that is the liquids which has to be separated should have lots of difference in the boiling point. That was the main principle. Now let's see the other method of separation. In that, what we are going to study is how to form crystals of certain salt, like common salt, NaCl, sodium chloride or copper sulfate, how the pure crystal from the impure substance can be obtained. So that method is known as crystallization. So if salt is obtained, we get salt from the seawater. So how you can purify the salt? So the purification of salts and all, like copper sulfate, potassium nitrate, calcium carbonate, all that can be done by using, that is by using crystallization method. So in crystallization, the main principle is there, you have to take the saturated solution of the salt. Here for example, I told you that is a saturated solution of copper sulfate solution. Saturated solution, how you can take the salt and dissolve it in very less amount of water, and then go on dissolving it till you reach a point where you will not be able to dissolve more of that substance. So you will get the saturated solution. Now take the saturated solution in an evaporating dish or china dish, place it on a tripod stand and start heating it slowly. So after some time, what you can see is the water vapor will start evolving, and then you have to carry out this process for at least 5 to 10 minutes. And then what you have to do is switch off the burner and allow this copper sulfate to cool. So first you have to heat the mixture, that is impure substance, which all impurities are there. You have to heat the mixture, and then the water vapors of the water will start evolving. Keep it for at least 5 to 10 minutes and then keep the substance for cooling. Cool the mixture. When you allow it for cooling, after some time you will observe very nicely the beautiful crystals of this copper sulfate, which is blue in color, that will be formed over here, and all the impurities will be left behind. So this is how pure copper sulfate can be obtained. Same way copper nitrate can be obtained. So crystalline, there are two kinds of substances, amorphous and crystalline substances. This is the best method of getting pure crystalline substances. So potassium nitrate is another thing, and sodium chloride, NaCl, salt from the sea water. So that and all can be purified by this method, and this method is known as crystallization. So the main principle in this, the pure salt of a substance, pure substance is obtained from the impure mixture from its saturated solution, and then heating it slowly and then allow it to cool. Nice crystals of this particular salt, copper sulfate or sodium chloride, can be obtained. So this method is known as crystallization. Next, let's study about the other method of separation. That is, you have already studied about distillation. Now, what happens when you have more than two liquids are soluble? So in that case, how you can separate the mixtures, we are going to study. So that method, that is two liquids, when it is miscible liquids, when it is mixed in a mixture, we take normal distillation, which has wide range of difference in the boiling point. But if there are more than two liquids which are present in a mixture, how can you separate it? That can be separated by fractional distillation. Fractional distillation. Fractional distillation, as the name suggests, fraction by fraction, part by part, the different components of a mixture, miscible mixtures are separated based on the difference in the boiling point. So, fractions of mixtures, that is components of the mixtures are separated one by one. And what is the main principle? Difference in their boiling points. Means suppose if the two miscible liquids don't have much of difference in the boiling points, that time what happened? You have to allow the mixture to heat it up, you have to boil it, it starts evaporation, and then the vapors which are formed, it has to be allowed to cool slowly, and then it has to convert into liquid state. So one by one, different parts of the component, more than one or more than two components if it is there, it can be separated. For example, fractional distillation is used in separation of components of petroleum. Petroleum, or it is also known as crude oil. So when petroleum is extracted from deep below the sea or deep below the earth and all, so what happened? It has lot of component in it. It's nothing but hydrocarbons. There will be ethane, methane, propane. Those are gases which are present. And maybe in our house also, you know, the gas cylinder, that is nothing but it's a mixture of propane and butane which is present. That is known as LPG. So it is liquefied petroleum gas, LPG. So that is under high pressure. Those two gases, mixture of propane and butane, are filled in the cylinder. That's what we are using in our house. Another, that is propane, methane, butane, and also there is ethene, butene, propene. All those are also components of, they are different components of petroleum. They are petroleum product. And in liquid state, you already know kerosene, petrol, gasoline is another one, and then all these are also diesel. These are also the different components of petroleum. So these components of petroleum can also be separated by this fractional distillation method. In this method, fractionating column is used, and the vapors of the different components of the petroleum is allowed to cool. So it's a fractionating column will be there, and these are the outlet for the different components of the petroleum to be removed. So when petroleum is heated, and there are also many asbestos sheet and all which will be placed. This is mainly placed for the gases, the vapors or the different components, the vapors of different components which will rise slowly, and it is allowed to cool, and it will be taken out by this. So different or more than two components can be separated by this method. This is known as fractionating distillation column. So the petroleum, when it is heated, the vapors will rise, and it will rise slowly, and then what happens when it reaches this end, it will be cooling. And on cooling, you can see that one part of that is the component of petroleum which has lower boiling point will be removed first. Like that, 1, 2, 3 different layers, different components of the liquid can be, and petroleum can be removed. And at the top of the fractionating column, different gases. The last one will be with one carbon, that is methane, can be obtained at top. So these all you will be studying in the higher classes, the different components of petroleum. It is mainly separated by means of fractional distillation. That is one application. The second application of fractional distillation is nothing but separation of components of air. Separation of components of air. Now, air is a mixture of gases. Okay, and then air itself, it is made up of different gases. In that you can see 78 to 80% of air is made up of non-combustible part of the gas, that is known as nitrogen, and 20% of the air or 19% of air. So you can tell 78 to 80%, 19 to 20% of air is made up of oxygen, which we breathe. Suppose we want to separate these mixtures of gases. We want to get nitrogen. Nitrogen is very important. It is used for making ammonia, NH3, which is used as a refrigerant in refrigerators and a cooling agent for storing, that is the food and all which is stored. So for cooling and all, this nitrogen, it is used for making ammonia. And you know that oxygen cylinder which is used in the hospitals and all. So from the air, these two components can be separated. Along with this, there are other gases also which are present in the air, which is in very less quantity, such as carbon dioxide, inert gases, argon, then neon. All are different inert gases which are present in the air. So all these components can be separated based on the boiling points, difference in the boiling point, and the boiling point is very less for this. So based on that, fractional distillation of air can be done to obtain nitrogen, oxygen, carbon dioxide or argon or neon, xenon, krypton. All those different inert gases can be obtained from air. So percentage, that is nitrogen is actually around 80%, 78 to 80%, and the percentage of oxygen in the air is around 19 to 20%. At different places there will be different variation depending on the pollutant present in that area. Now that is one, and based on the difference in the boiling point. Now the boiling point you can see here, that is nitrogen gas has the least boiling point, that is minus 196 degrees Celsius. And then there is argon, it is a inert gas, the boiling point is nearly, it will be equal to minus 186 degrees Celsius. Next comes oxygen. Oxygen, the boiling point of that is minus 183 degrees Celsius. And then carbon dioxide, at that temperature what I am writing, that is also it's known as dry ice. Okay, so that is around minus 78.6 degrees Celsius. So this is least one is nitrogen, and then the highest I can tell in this is all are in the negative. Minus 78.6 is the boiling point of carbon dioxide, minus 183 degrees Celsius is oxygen, minus 186 degree Celsius is argon, and nitrogen minus 196 degree Celsius is for nitrogen. All these gases are compressed, it is converted to liquid state, again it is made to expand, and then on cooling the vapors of these gases, the gases can be obtained in the component. So I just draw the flow chart and then you can see the diagram and then you can understand it. So here how the fractional distillation of air is done is, air is taken and it is compressed. Okay, air, you know, the molecules are very far away, so when pressure is applied on it, so the molecules will move closer. It will be changing into liquid air. And how it is compressed? Under high pressure and low temperature. Temperature is lower. So under these conditions, air is compressed and changes into liquid air. And then what happens slowly, this liquid air is made to expand. It is made to little bit temperature is given and it is made to expand. So air expands. In which column? Distillation column on heating. And slowly by slowly, that is liquid air which is having all different components, the percentage is there, the different components of the air has different boiling points. So when it is heated, it expands and slowly by slowly the vapors are cooled and collected. So how the vapors will be collected? Which will be the first gas to be collected, which has the first gas to be collected, that is carbon dioxide, because its boiling point is nothing but minus 78.6 degrees Celsius. This will be the first gas which will be collected, that is the boiling point is minus 78.6 degrees Celsius. Next is oxygen, minus 183 degrees Celsius. When the temperature reaches this, the oxygen gas will be separated and it will be collected over here and on cooling. Next gas which will be obtained is third one, argon. It is a noble gas. That will be around minus 186 degrees Celsius. And last one, you can see the fourth gas which will be separated from this is nitrogen. So the boiling point of nitrogen is minus 196 degrees Celsius. So nitrogen also has very low temperature. It is all are in the liquid form: liquid nitrogen, liquid argon, oxygen, and carbon dioxide. At this temperature, carbon dioxide is known as dry ice, which I showed you the image in the last slide. So the first one to be cooled and obtained is carbon dioxide, then oxygen, then argon, and then nitrogen. So this is the method of fractional distillation when more than one component forms a uniform or homogeneous mixture having a difference in their boiling point can be separated. Hope you have understood this much. Now I want all of you to look into the slide and understand the concept very well. So now children, look at the slides. So today we have studied about three methods of separation of mixtures: fractional distillation, separation of different components of the air, and crystallization. Now the first method, fractional distillation. In fractional distillation, as the name suggests, fractional, there is also one extra fractionating column added with the distillation flask. This is a distillation flask where the mixture of two miscible liquids having less range in their boiling points, difference in the boiling point is taken in the distillation flask. Additional setup is one fractionating column is kept above the distillation flask. It is attached carefully, and this fractionating column has beads. It is filled with the beads to allow the vapors to rise up very slowly and to cool also very slowly. So that is the main purpose of this fractionating column. And above the fractionating column, the thermometer is kept to read the temperature, boiling point of the two or more than two liquids which is there. For that, thermometer is placed. And then here, by the side of the fractionating column, it is the tube which passes through the condenser, Liebig's condenser. Liebig's condenser is nothing but here the cold water will enter through this inlet, and then it will cool the vapors which flows in through this thin tube, and the water becomes warm and it flows out through the water outlet. The cool vapor which passes through the thin tube, it condenses here, and here it changes into liquid and is collected in the receiver flask. So in this experiment, the mixture of two miscible liquids are taken in the distillation flask and it is heated slowly by using the burner. And then after some time, you have to observe the temperature carefully. So when the boiling point of the liquid which is having lower boiling point, that will start forming the vapors first and it will rise through the distillation flask and enters the fractionating column very slowly because of the presence of the beads. And then slowly it passes through this thin tube. As it enters the Liebig's condenser, the cold water circulates around the thin tube and it cools the vapor of acetone, and that changes into the liquid state and it will be collected in the receiver flask. And here, this is the inlet for the cold water. The water gets warmed and water is sent out through the water outlet through this tube. Now here what happened at the end of the experiment, the component which is having higher boiling point will be left behind in the distillation flask, and the component which is having lower boiling point will be collected in the receiver. So only one additional attachment is this fractionating column. So this method is known as fractional distillation, one by one. If there is more than one miscible liquid also, or two or more than that, 3 or 4, so this method can be used, and one by one the different components of the mixture can be collected based on the boiling point. Now, what is the principle of fractional distillation? Fractional distillation is used when the difference in the boiling points of two or more miscible liquid is less than 25 Kelvin, and fractional distillation process is used for separating such miscible liquids. Now, where we are using fractional distillation, or state the application or uses of fractional distillation. Fractional distillation is used for separation of different gases from the air. That's very important, and will be discussing about that. Now, it is used for separating petroleum products from petroleum. So, petroleum products like kerosene, petrol, diesel, wax, gasoline, methane, ethane, butane, all those are different components of petroleum. So, that is a crude oil. So, all that can be separated by using this separating, that is a fractional distillation. Now, air which is having nitrogen and oxygen. So, oxygen gas can be separated from the air by this fractional distillation method. Now, as I told you, two or more miscible liquids having less difference in the boiling points are also separated by fractional distillation like petrol, diesel, kerosene, etc. Let's learn about this in this following picture. Now, this picture, you don't have to draw it, it's just for you to understand. This is the fractionating column. Okay, how the petroleum is nothing but crude oil which we get from the earth and all. So after the extraction, that crude oil is taken and it is heated by the help of this heater. And this whole thing is known as fractionating tower. And fractionating tower, see here, these are the asbestos sheet which is placed in between for allowing the different components of the petroleum, the vapors when it is heated, to rise up slowly, and it will be collected one by one, like first one, second, third, fourth, based on the difference in the boiling point. So see the procedure now. So the crude oil which is taken, it is heated and then it is allowed to cool, rise up in the fractionating tower. So what happened? The component of the petroleum which has less boiling point, the vapors of that will start rising up first and will be collected over here. So suppose it's 20 degree, so refinery gas will be collected on the top first. So this is used as a fuel in LPG, that is the gas cylinder which we are using in a home, and it is nothing but it's a mixture of propane and butane. So LPG is nothing but liquefied petroleum gas, which is a mixture of propane and butane, that is obtained by fractional distillation method. The next component of petroleum which will be separated will be at 70 degrees Celsius. Petrol will be formed. You know that petrol where we are using in scooter, buses, truck and all that, will be using it. Even in the buses and all, normally diesel is used. Petrol is used in the car, scooter and all. You have seen it. So petrol will be separated at 70 degrees. Next at 120 degrees, naphtha component is a chemical, will be separated. It is used to make chemicals like mothballs to kill the insects. Next, when the temperature rises up at 180 degrees Celsius, another component of petroleum, that is kerosene, will be evolved. The vapors will be evolved and then it will be cooled and to be collected over here. So see, so wide range of components are obtained based on the difference in the boiling point. So kerosene is used as jet fuel, paraffin for heating and lighting, for kerosene stove is there, kerosene lamp is there. So all that kerosene is used for that. That is also one of the petroleum product. Next, when the temperature boiling point rises at up to 260 degree, the vapors of diesel will start cooling and will change into the liquid state and to be collected. So diesel is used for the engine. Next, at 300 degrees Celsius, the other component of petroleum will be separated. What is that? Lubricating oil. You know, lubricating oil is used in the car, machine parts and all. Oil is used for preventing rusting. Grease and all is there, no? So that is used for as lubricating oil. Then when the temperature reaches at 350 degrees Celsius, another component of petroleum, that is fuel oil, will be separated. The main use of fuel oil is used in the ships and in certain factories. Last one, in the end, some residue, that is after all this fractionating column, when all these things are separated, there is some extra component residue product is formed, that is used for to make bitumen and asphalt. Where it is used to make road. You must have seen the tar and all, black color tar. So that is nothing but that is also a petroleum product. So this is one of the uses of fractional distillation. You don't have to draw it, it's just for you to understand. Next one, this is important, which you are going to study, that is how to separate different components of the air by fractional distillation. So the different components of the air is nothing but nitrogen, oxygen, argon, carbon dioxide are present in the air. So these different gases have different boiling points. For example, the lowest boiling point is nitrogen. It is as low as minus 196 degrees Celsius. Argon, one of the noble gas, the boiling point of that is little bit more than nitrogen, minus 186 degrees Celsius. Oxygen boiling point is minus 183 degrees Celsius, and carbon dioxide is minus 78 degrees Celsius. So this is how the fractional distillation column is there. It will be first the air will be made to cool and then it is made to warm up. So let's study that properly. So this flow chart is the one how the different components of the air is separated by fractional distillation. Now air is nothing but it is a homogeneous mixture of various gases. Homogeneous means it will form a uniform layer, but air has so many different gases in it. It has 78% of nitrogen in it, nearly 21 that is 18% of oxygen in it, 1% it is having other gases, and then it has noble gases also, carbon dioxide, sulfur dioxide, many pollutants are present in the air, but it forms a uniform mixture, homogeneous layer. So how to get different gases from the air? Oxygen, argon, nitrogen, how we can get it? So this is a flow chart for you to understand. First air is taken, it is compressed, it is pressed under pressure, it is compressed, and air is cooled by increasing the pressure and decreasing the temperature, and then you will get liquid air. This liquid air is allowed to warm up in the fractional distillation column. And then what happened, based on the difference in their boiling point, different gases will be collected according to their boiling point. So out of the three gases, oxygen, argon and nitrogen, the oxygen gas will be separated first. That is, it has the higher boiling point than nitrogen and argon. So when the temperature reaches to minus 183 degrees Celsius, oxygen will be the first gas to liquefy and it will be collected. Next, when the temperature reaches around minus 186 degrees Celsius, another noble gas or inert gas, argon, it will separate and then it will turn into liquid and it will be collected. And next one is nitrogen. So nitrogen will be the last one to be collected and last one to liquefy. So gas will be converted into liquid. So at minus 196 degrees Celsius, nitrogen gas will be collected. So let's see the diagram of this. So this is the diagram of fractional distillation of air. You don't have to draw it. So here what happened, air is taken through and then it is filtered and air is allowed to, it is compressed under high pressure. This is a compressor. Under high pressure, air is made to compress and slowly it is made to heat up. It is made to warm up. And then hot air enters this column and then what happened, this is the tube of cold water. This cold water, that is freezing cold water, runs in through this tube and it becomes warmer and it will go out through this outlet. So what is the main purpose of this? This hot air is allowed to cool in this column. So from here what happened, air enters through this, it will get cooled and it will go through this cold compressed air will come out through this chamber, through this tube, and then it will enter into a column known as separator. Now in separator what happened, based on the boiling point of different gases, the different gases will be separated out. So if carbon dioxide is there in that, if it is present, what happened, carbon dioxide will be collected first. So when it reaches around 78 degrees Celsius, carbon dioxide will be removed and you know what is called carbon dioxide gas? At that temperature, it will be in the solid state and it is known as dry ice. So liquid carbon dioxide is formed and then it sublimes. Okay. Next one, the next column, the separator, the mixture of gases comes out and again there will be an expansion jet. The air will be made to expand. That is, the pressure will be decreased and then in this column what happened, here the next gas to be separated will be oxygen. That is, liquid oxygen will be obtained over here at minus 183 degrees Celsius. And then the third gas will be argon will be removed out at minus 186 degrees Celsius. And when the temperature, it becomes even more very lower, that is minus 196 degrees Celsius, nitrogen gas will be removed. So fraction by fraction, different components of the air is removed. So it is known as fractional distillation. So these are the two main examples of fractional distillation which you have learned. Now, As I told you, what is the percentage of various gases in the air? This is important, learn it properly. So you can see here nitrogen in the different gases which you can see here is nitrogen is major. It is nearly 4/5 of the air consists of nitrogen, that is 78%. Oxygen is 1/5, that is 21%. Argon is a noble gas, 0.9%, and carbon dioxide very less, that is 0.035%. These are the various components of the air which is present, components of gases which is present in the air, and that can be separated by fractional distillation. Now, what is the boiling point of the following gases which is present in the air? So you have to learn it properly. It will be asked for all MCQ questions needed for higher classes. So the boiling point of oxygen gas is minus 183 degrees Celsius, argon is minus 186 degrees Celsius, nitrogen is 196 degrees Celsius, and carbon dioxide has the highest one among this, that is minus 78.46 degrees Celsius. So the lowest boiling point is nitrogen and highest boiling point among all these gases is carbon dioxide. So now in which order if we want to arrange the gases present in the air in the increasing order of the boiling point, how we can arrange it? So increasing order means it should be from lowest temperature to highest temperature. So nitrogen is the first one at minus 196 degrees Celsius. It is argon is the next one at minus 186 degrees Celsius, oxygen minus 183 degrees Celsius, and carbon dioxide minus 78.46 degrees Celsius. Now in the fractional distillation column, which gas cools first and forms the liquid first as the air is cooled? So carbon dioxide gas is the first one to cool and form liquids first as air is cooled in the fractionating column. Which gas forms the liquid and collected last as the air is cooled? Nitrogen gas cools last and forms a liquid when the air is cooled based on the boiling point. Next, let's study the next method which we have learned is crystallization. Now, crystallization is a process of getting the pure crystals of a salt, like the common salt, sodium chloride. Sodium chloride, we get it from the sea, and when we take the salt from the sea, there will be so many impurities in it. So, in order to purify to get pure salt, this crystallization is the best method than evaporation. If evaporation is carried out along with the salt, some of the impurities also will stay back. So that is very difficult to remove. So better than evaporation, crystallization is a process. So here it's an example of getting pure copper sulfate salt through crystallization. Now what happened in crystallization? You have to take a beaker and then you have to keep a china dish or evaporating dish on top of it. The beaker where you have to pour little water for boiling. Directly if you heat it, there's a chance of decomposing. So you have to heat it by heat the china dish by keeping it over a beaker, and inside the china dish take copper sulfate solution, take copper sulfate salt and impure sample, dissolve it in very less amount of water and start heating it slowly using the burner. After some time you can see it, you go on heating it, and after some time just cool the mixture and allow it to cool down for some time at the room temperature. And then very nicely after some time you can see nice crystals of copper sulfate will be formed. So first you have to make a saturated solution of copper sulfate. You have to go on dissolving copper sulfate in the water till no more copper sulfate dissolves. That is known as saturated solution. That only you are heating it, and afterwards you can see the pure crystals of copper sulfate solution form. This is a pure form of any salt which can be obtained. Now what is the principle of crystallization? So the aim and the aim is to obtain pure copper sulfate crystals from a impure sample. Crystallization process is used to separate a pure solid in the form of its crystal from a saturated solution on heating and then cooling the solution. Now what is a method? Take some impure sample of copper sulfate in a china dish, dissolve it in minimum amount of water, filter the impurities out. Next, you have to evaporate the water from the copper sulfate solution so as to obtain a saturated solution. After that, cover the solution with the filter paper and leave it undisturbed at the room temperature and allow it to cool slowly. So what do you observe? State your observation on cooling the saturated solution of copper sulfate solution. So on cooling the saturated solution of copper sulfate in the china dish, crystals of pure copper sulfate is obtained. Can you see this? Beautiful. Why? That is the blue color. Copper sulfate, the crystals will be formed and it can be taken out, and then can be made to dry to remove the moisture. So these are the crystals of pure copper sulfate. So like the salt or pure salt also is formed by this method. Now these are some of the pictures of pure crystals of salt which is formed. So you can do this experiment at home, but with the help of your parents. You can take a dish and then add little salt in it, make a saturated solution, and you can add little color, red, blue, green and all that, and allow it to heat it slowly, and then allow it to cool for some time. Then you can get crystals of these salt after some time. You have to make a nice saturated solution and then try it out. These are also crystals of other salt like potassium nitrate, potassium chlorate. This is nothing but copper sulfate which is formed. That is a pure copper sulfate which is formed by this method. And here also crystals of salt which is formed. So different kind of crystalline salts can be prepared by this method. There are two kinds of salt which is present, amorphous and crystalline. This method is used for only making crystalline salt. So it's soluble in water. Now, what is the uses of crystallization? Crystallization method can be used to purify solids, to obtain pure salt from seawater, to obtain pure crystals of salt like salts like copper sulfate and potassium nitrate, and for separation of pure crystals of alum from the impure sample. Alum is used for purifying water. When there is lot of dust or mud inside the water, alum is a chemical. You have to just take it and just stir it in water. And after some time you can see the dust or the mud will settle down at the bottom of the container. So alum is used for purifying water. Why is crystallization better than simple evaporation technique? Crystallization is better than simple evaporation technique since some solids decompose and some solid like sugar gets charred. When you heat sugar, it will turn into brown color. So we cannot use evaporation. Crystallization is better method of making sugar crystals and all. Then some impurities may remain dissolved in the solution even after filtration, and on evaporation these impurities contaminate the solid. So always crystallization is better than evaporation to get the pure salt like copper sulfate, potassium nitrate or sodium chloride. So I hope all of you have understood this method. Now please copy the notes neatly, draw the diagrams of only the flow chart and the crystallization method, and complete the notes and send the notes to me through the WhatsApp. So please start learning all these steps properly and be well prepared for the online test. Now this is a worksheet question. So read it, understand it and then attempt it. You have to copy the question and write the answers in your notebook. So here name the method used to separate the following mixtures. Go through the notes and then write it down. Oxygen gas from air, petrol from petroleum, pure salt from seawater, alum from impure samples. And now the second question, you have to state the boiling point of the following gases: oxygen, nitrogen and carbon dioxide. Hope you all remember this. So learn properly and then complete your notes. You have to copy all the notes neatly in your notebook, solve the worksheet and write the answers in your notebook. Read the notes and textbooks well till page number 23 and learn all the spellings of all the keywords. Thank you children.